Kia ora team, welcome back. Just quickly run over yesterday's work. So the instructions were, as you can see briefly on here, to complete this table, softball examples and other important information just over here. We will cover this again next week, Newton's laws, and these obviously the very basic form of how everything works. Within sport, today's instructions you'll see there, but it's to basically complete this page, complete the law of reaction, and then finally you can just complete this page here as we go through it. And there's a small quiz to do because we do have upcoming common tests next week, as I've been explaining. So just quickly cover yesterday's due work. Thanks for all those who have submitted it. We've got our two sumo wrestlers here. Although very different in what would say mass. We would say who's more inertia. When we look at inertia, it's mass, and inertia is basically the body's tendency to remain in a present state, or its resistance of the body to change. So we'd say this individual on the right has a much larger mass than this one on the left. So he needs a larger force to move his inertia or his mass through that side. If we do have another look and we look at this further, we can see that an individual in rugby, John Lomu here, had a much larger inertia than his other ones. And you'll see today when we look at the third law of reaction, when we have Newton's third law, this will explain it a little bit further on why it's so hard to slow him down. But his mass was a lot larger. He was 120 kgs, and he could move that mass very quickly. Over 100 meters, you could run it in 11.2 through this one here. Let's quickly back to our next question. 2. What was the external forces that a rugby kicker has to think or have to think about when kicking the ball? Again, the main point I was trying to get across here was that the ball obviously won't move unless acted upon by an external force, but in the air, this is a projectile, and this rugby ball will have to contend, or the kicker will have to think about air resistance. Again, that can vary, but is consistent if there is no wind, and also gravity in its air, and obviously that'll dictate what direction the release angle he'll kick that from. Again, you think about this when you throw a softball and the angle of release you throw it from and the force needed to get to the person's glove. Next point, question 3, asks if a batter misses the ball, what forces are going to slow it down? And this is related to the question we just answered. So the backstop will stop with his glove, and that will likely relate to what you're going to cover today in today's lesson, a reaction force. If he misses it, the batter, then air resistance and gravity are going to act on that ball, and then it's going to come crashing to the ground, and we're going to get a reaction from the ground. Number 4, if you apply equal force to a dry tennis ball and an equal force to one that is wet and sodden, which one will travel further and why? Again, this was related to law 2 and around law 1. A dry one will actually travel further due to the reduced mass of it. So, reminding you again of law 2 of acceleration, Newton's law. The ball is proportional to the force applied on it. Both balls have equal force applied, so the lighter one with less mass will accelerate faster, traveling further. All the best with today's work, and again, as I keep emphasizing, make sure you're getting out there, even if you're poor. Probably best to get out this morning or later this afternoon and head out for a run or a quick circuit, and make sure if anything, you're doing those Grammar Fit workouts that are being posted. Thank you very much. Any questions, as always, email me or put on the social stream. Thank you very much.